In this lesson, we're going to be talking about a constant rate of change. When you have data that forms a straight line, we say that the rate of change is constant. What is the constant rate of change in the following graph? The rate of change will be written in the form of y over x. So what we want to look at is we want to find 2 points on our graph. Let's say that we find that the allowance paid for a 9-year-old is $6. And let's say the second point we want to use is that a 12-year-old would be paid $12. What we want to look at is how much the y, remember this is the y-axis, and this is the x-axis, how much the y changed going from 9 to 12 years old. So if we look at our numbers here, on our y-axis, the amount of allowance went up from $6 to $12. So that would be an increase of $6. Now, how many years did that take place? So now we want to look at our x-axis, and we're going up from a 9-year-old to a 12-year-old, and so that would be 3 years. Now we reduce this fraction, and this tells us that the constant rate of change was $2 per year. It's important to have the dollar sign and also to show that it was per year, because that's called interpreting your answer. Do you know what you're talking about? Do you know what constant rate of change is? Yes, I do. I know because this is a change of $2 per year. When looking at a table, we're going to do the same thing. For the constant rate of change, remember that the form is going to be y over x. So remember, if you look at our chart here, we have gallons and quarts, and it's also noted that the gallons is the x column and the quarts is the y column. So looking at my quarts, I want to see how much it's gone up. So from the first to the second gallon, it's gone up 4 quarts. And then I go ahead and look at my x, and going in that same direction, it's gone up from 1 to 2 gallons. So that would be an increase of 1 gallon. And so that means that my constant rate of change is 4 quarts per 1 gallon. The second part of our question is asking whether the data is proportional. In order to take a look to see if the data is proportional, we want to look at each row and see what the rates are. So for our first row, we have 1 gallon is 4 quarts. Then we have 2 gallons, goes with 8 quarts. 3 gallons with 12 quarts, and 4 gallons with 16 quarts. Now, if all of these rates are equal, then that means our data is proportional. Since 1/4 does equal 2 eighths, which equals 3 twelfths, and equals 4 sixteenths, we say yes, the data is proportional. Let's go ahead and try a couple more together. For number 3, the graph that we see is talking about the number of teachers per student. In order to find the rate of change, remember we want to write this in the form of y over x. So we first have to look at the teachers and compare it to the students. So we pick 2 points on our graph to start with. Let's go ahead and take a look at these 2 points. I notice that the number of teachers has gone up from 1 to 2, and so that would be an increase of 1 teacher. And our x value for those same points has gone up from 20 to 40, so that would be an increase of 20 students. We'll just put ST. So that means that the rate of change is 1 teacher per 20 students. And that would be our answer for that part of the question. The second part of the question is asking if the data is proportional. One way to look at this is if our straight line goes through the origin of the coordinate plane, the origin, remember, being right here in the corner by 0, 0. If the line goes through that point, then yes, we say that it's proportional. The other way to do it would be to go ahead and set up the fractions. So we have 1 teacher with 20 students The next point is 2 teachers with 40 students. The next point on the graph would be 3 teachers at 60 students, etc. And since all of those fractions are equal, we can say the data is proportional. One more example together. In the chart here, we have width in feet and height in inches. To find the rate of change, we're going to look at the y column and then the x column. In the y column, going from 10 to 14, that would be an increase of 4 inches. I get the inches by looking at the top of the column. In the x column, our increase is from 2 to 4, so that would be an increase of 2 feet. So therefore, after reducing this, when we do 4 divided by 2, we get 2, and then we would say the rate of change is inches per foot. Now, is the data proportional? In order to do that, remember we look at each row as a fraction. 2/10, 4/14, 6/18, and 8/22. Are these all equal to each other? Well, 2/10 equals 1/5, and 4/14, if I divide them both by 2, I get 2/7. 1/5 and 2/7 does not equal each other, so that means that I would say no, this is not proportional. For the following examples, I would like you to pause the video and go ahead and find the rate of change and say if the data is proportional for each of the following examples. After you've done so, go ahead and unpause the video so you can check your answer. Okay, we're ready to go. So, to find the rate of change for the first one, we're going to do y over x like we did before. We're going to pick 2 points on our coordinate grid. Our change for the y has gone up by 15, so $15. And with those same points, looking down here, the number of cars washed has gone up from 2 to 4, so that would be a change of 2 cars. Once I go ahead and divide these, I get $7.50 per car. That is my rate of change. Now, to see if the data is proportional, I see in the corner that I have 0, 0, and the line goes through that right here. So that means yes, the data is proportional, or I could check it by writing the fractions. 2/15, 4/30, 6/45, etc. And since all of those are equal, then we go ahead and say that we have a proportional relationship. For the second example, let's go ahead and do our y over x. Looking at our y's, I see that it's going up by 2 yards. And looking at my x's, I see that it's increasing by 1.2 seconds. After I go ahead and divide 2 by 1.2, I end up with a repeating decimal. And so how I'm going to write that is I'm going to say that it is 1.6 repeating yards per second. That is my rate of change. Now to check to see if the data is proportional, I have 1.2 over 6. I want to know if that equals 2.4 over 8, 3.6 over 10, and 4.8 over 12. Since these are a little bit more complicated, I would recommend using your calculator. Take 1.2 divided by 6, and that's going to equal 0.2. When you take 2.4 and divide by 8, you get 0.3. Since those are not equal, we say no, the data is not proportional. In order to write an equation for a proportional relationship, we need to keep in mind that the form of the equation is going to be y equals the unit rate, which is noted by k, times x. So in order to write an equation, we have to know the unit rate first. In this example, it says that the cost of paper varies directly with the number of reams bought. Suppose 2 reams cost $5.10. Your first step is to find the unit cost. In order to find the unit cost, remember we take $5.10 and divide by 2. That gives me a unit cost of $2.55. I'm going to use this in my equation where the k is. Now, what's nice about these equations is that the y and the x are going to stay the same. So my equation is going to be y equals $2.55 times x, where y represents the total cost and x represents the number of reams of paper. So this is my equation right here. In order to answer the next question, it says find the cost of 15 reams of paper. So what I'm going to do is use my equation that I just wrote, and for x, I'm going to plug in 15. So if I take $2.55 times 15, I get $38.25, and that is in dollars. So I have my equation, and then I also have solved for 15 reams of paper. Okay, you go ahead and try this next one. The cost of ground beef varies directly with the number of pounds bought. Suppose 3 pounds cost $11.94. Go ahead, find the unit cost, then write an equation that could be used to find the cost of X pounds of beef, and then find the cost of 7 pounds. Pause this video, do the assignment, and then go ahead and check your answer. Okay, so the very first thing we need to do is find the unit cost. In order to find the unit cost, we need to take $11.94 and divide by 3. This is going to tell us how much 1 pound of beef costs. After calculating, the cost is $3.98. Now that we have our unit cost, we're going to go ahead and write our equation. Remember, the equation needs to be in the form y equals kx, where the unit cost, $3.98, that's what k is. So y represents the total cost. So we have y equals, then we put in our unit cost, $3.98, and then we have x, and x represents the pounds of beef. This is our equation. Now we can answer our last question, which says find the cost of 7 pounds. So if we plug in 7 here for x, we end up with $3.98 times 7, and so our cost is $27.86 for 7 pounds. Okay, now here is the last problem. It says, recall that the length of a spring stretches, and that varies directly with the amount of weight attached to it. A certain spring stretches 5 centimeters when a 10-gram weight is attached. Write a direct variation equation relating the weight, x, and the amount of stretch, y. So in order to do this, we first need to find out how far the spring stretches when 1 gram of weight is attached. We can do this by taking 5 centimeters and dividing by 10 grams. That's going to give us 0.5 centimeters per gram. This is our unit rate. So now to write the equation, we're going to go ahead and say y equals 0.5x. Now estimate the stretch of the spring when it has a 42-gram weight attached. So we know that the weight is 42 grams, and so we want to substitute that in for x. So y equals 0.5 times 42. So y is equal to 21 centimeters. And that is the end of our lesson on constant rate of change.